This is our first question. If k is a 0 of the polynomial, p of x equals to x plus 3, find the value of k. So here a polynomial is given, p of x as 2x plus 3. And k is said to be the 0 of the polynomial. That means p of k is 0. That means in place of x, if we give the value k, then we have to get a 0. That is 2k. See, in place of x, we have to put k. 2k plus 3 equal to 0. Then what will be k? 2k is equal to, we have to take this 3 to the other side. Here 3 is positive. When it is taken to the other side of the equal to symbol, it will become negative. So 2k is equal to negative 3. So k is equal to minus 3 by 2. This is the next one. A graph is given. We have to find the number of zeros. Number of zeros means the points where the graph or the plot touches or crosses the x-axis. So here, see, this point is a 0 of the polynomial, and this point is also a 0 of the polynomial. Then here, so how many zeros are there? See, 5 places. That means 5 zeros are there. This is the next question. X square plus a plus 1 into x plus b. If 2 and negative 3 are the zeros of this quadratic polynomial, find a and b. Okay, so this is the given polynomial. Let us take it as p of x equals x square plus a plus 1 into x plus b. And it is given that 2 and minus 3 are zeros. That means p of 2 is equal to 0. So let us consider what is p of 2. In place of x, we have to give 2. So it is 2 square plus a plus 1 into 2 plus b. See, wherever we have an x, we have to give 2 there. So it is 4, because 2 square is 4. Then a plus 1 into 2 plus b. So we can equate it to 0 because 2 is a 0. That means in next step, let us open this bracket. So 2 will come here. 2 into a like that. So it is 4 plus 2a plus 2. See, 2 into 1, 2 plus b is equal to 0. So 4 plus 2 equal to 6. So 2a plus b plus 6 equal to 0. This is one of the equation, or the equation which we have deduced from the given data. So let us take it as first equation. Then again, it is given that p of negative 3 is also 0. So p of negative 3. That means in place of x, we have to give negative 3. So it will become minus 3 square. See here, x square became minus 3 square. Then plus a plus 1 into negative 3 plus b. Right? And this is also 0. That means negative 3 square. Minus 3 into minus 3, positive 9. So it is 9 plus negative 3 into a plus 1 plus b equal to 0. Because p of negative 3 is equal to 0, because my negative 3 is also a 0 of the polynomial. Now in the next step, we will open this bracket, negative 3 into a like that. So 9, negative 3a, right? Minus 3 into a minus 3a. Then negative 3 into 1, that is minus 3, then plus b equal to 0. See, 9 minus 3, that is 6. 6 minus 3a plus b equal to 0. Okay, so if we rearrange these things, we will get minus 3a plus b plus 6 is equal to 0. See, we have got two equations from this given data. Now we have to find out the value of a and b from these two. Here we have a b, here also we have b. So let us subtract. Okay, so let us subtract from first equation the second one. This is the second equation. So when we subtract 2 from 1, that is 1 minus 2, what we get? 1 minus 2. See, 2a minus minus 3a. 2a minus minus 3a, right? Then b minus b. So b got cancelled. 6 minus 6. 6 also got cancelled. So what we get? 2a minus minus 3a equal to 0. That means 5a is equal to 0, or we can say a is equal to 0. Thus we got the value of a as 0. Now if we give that value here, what happens? First equation or second equation, whatever, whichever is convenient for us, we can follow that. So a is equal to 0. Let us give that value here. So in second equation, minus 3 into 0 plus b plus 6 equal to 0. See, minus 3 into 0 became 0. So b plus 6 equal to 0. That means b equals negative 6. Thus we got the value of a and b. This is the next one. 5x squared plus 13x plus k equal to 0. If one root is the reciprocal of the other, then find the value of k. See, one root is the reciprocal of the other. We know alpha, beta. Normally, we take the roots as alpha and beta. And we know the relation between them. Alpha plus beta equals minus b by a. And alpha beta equals c by a. If one root is the reciprocal of the other, then what? Alpha can be taken as 1 by beta, right? Alpha is same as 1 by beta. So if we apply it in alpha beta relation, alpha is 1 by beta, right? In place of alpha, we can give 1 by beta into beta is equal to c by a. See, what is alpha? 1 by beta into beta. 1 by beta into beta is 1, right? We can cancel this. So what we get is c by a equals 1. Okay, now let us take the value of a, b, and c here. Here, a is 5, b is 13, and c is k. So what is c by a? C is 5, and a is 5. C is k, sorry, c is k, and a is 5, and it is 1. So k by 5 equals 1, or we can say k is equal to 5. When this 5 is taken to the other side, 1 into 5. Right? So k is equal to 5. That is the answer. Next few questions are true or false type questions. Ax squared plus bx plus c. If the zeros of the quadratic polynomial are both positive, then a, b, and c have the same sign. Okay? This is what we have to check whether it is true or false. Both the zeros are positive. It is given like that. Both the zeros are positive. That means alpha, beta both are positive. Then we know alpha plus beta is minus b by a. See, sum of the zeros is negative. That won't happen if both of them are positive. If alpha and beta both are positive, then their sum can never be a negative number. So the answer is false. This statement is false. Now comes this next question here. If the graph of a polynomial intersects the x-axis at only one point, it cannot be a quadratic polynomial. If the graph of a polynomial intersects the x-axis. So we know the zero of the polynomial means the point where it touches or intersects the x-axis, right? So here it is said that it intersects the x-axis at only one point. Then it can be a quadratic polynomial like this. See, at one point only it touches x-axis. This happens when both alpha and beta are same. When both the zeros are equal, then it can touch or cut the x-axis only at one point. So this statement is again false, because in this statement it is given that it cannot be a quadratic polynomial, but actually it can be a quadratic polynomial. Possibilities are there. Then the next one, if the graph of a polynomial intersects the x-axis at exactly 2 points, it need not be a quadratic polynomial. True or false? Okay, so we know there are 2 zeros for a quadratic polynomial. Sure, but it touches or cuts the x-axis exactly at 2 points doesn't mean that it is of course a quadratic polynomial. It can be polynomial or something else, right? It can be a so the statement is actually true. It is given that it need not be a quadratic polynomial. That is true because it can be a cubic polynomial or something else. So it is true actually. This is our next question. If two of the zeros of a cubic polynomial are zero, then it does not have linear and constant terms. So the question is about cubic polynomials. We know normally we take alpha, beta, and gamma as cubic polynomial zeros, right? Alpha, beta, gamma. And normally we can represent a cubic polynomial as x minus alpha into x minus beta into x minus gamma. Okay, this is the normal form of a cubic polynomial in factorized form. So here it is given that two zeros are zero itself. That means alpha can be taken as zero, then beta can be taken as zero. Okay, so what happens? We have here in this expression alpha and beta as zero. So x minus zero into x minus zero into x minus gamma is the required cubic polynomial. Now let us check what happens here. This is x, right? X minus 0 is x. This is also x. So x into x. Then again x minus gamma is here. So finally x into x square is there into x minus gamma. This is our required polynomial. Now what happens? Let us expand it. X into x cube, x square into gamma, that is minus x square gamma. This is the required polynomial. Here let us see, we can see that there is no constant term, there is no linear term. Linear term is what? Linear term means the term with x. There is no x terms here, right? So there is no linear term and there is no constant term. So this given statement is actually true. This is the next one. If all the zeros of a cubic polynomial are negative, then all coefficients and the constant term of the polynomial have the same sign. We know these are the relation between the three roots of a cubic polynomial: alpha plus beta plus gamma minus b by a, alpha beta gamma minus b by a, alpha beta plus beta gamma plus alpha gamma equal to c by a. So from the last expression, see, from here itself we can deduce the answer. See, here if all of them are of same sign, then only it is a positive, right? C by A will become positive only when all of them, alpha, beta, both are negative means alpha, beta is positive. Beta, gamma, both are negative means beta into gamma is negative, like that. Okay? If any of the root is negative, then we cannot strictly say that this is positive, right? And in the question it is given that if all the zeros of a cubic polynomial are negative, if all of them are negative, then this is also positive. If, see here, in this expression, alpha, beta, gamma, if all of them are negative, if three of them are negative, means three negative numbers when got multiplied, we will get a negative number, right? So here also like that, when all of them are negative, this is, of course, it will be a negative number. That means if all of them are negative, then all the coefficients and constant terms of the polynomial have the same sign, right? Otherwise, this negative term will be changed, right? Suppose if D is negative and A is positive, that means this will become minus of minus D by A. That means when we multiplied three negative numbers, we should get a positive thing. See, negative to negative, positive. That won't happen, right? That means we can say the given statement is true. To follow these equations correctly, the given statement should be true. So if the three zeros of the cubic polynomial are negative, then all the coefficients and constant term of the polynomial have the same sign. So this is true. This is the next one. x cube plus ax square minus bx plus c. So in place of a, we have 1. In place of b, we have a. In place of c, we have minus b. And in place of d, we have c. If all three zeros of this cubic polynomial are positive, then at least one of a, comma b and c is non-negative. So we know the relation between them is like this: alpha plus beta plus gamma equals negative b by a. In place of, in this given expression, in place of b we have a, and in place of a we have 1. So minus b by a will become, automatically become minus a by 1. That is negative a. See, alpha, beta, gamma, all the three are positive. It is given in the question, are positive. That means alpha, beta, gamma should be positive. So in order to make it positive, what happens? A should be negative. Otherwise, this won't be positive, right? So A is negative. So A is negative. Now, let us check this equality. Alpha, beta, gamma equals minus b by a. In place of b, here we have c. So it will become minus c by a is 1. Okay. So minus c. See, alpha, beta, gamma, all the three are positive. When we multiply, we should get a positive number. That means here c should also be negative. Otherwise, this won't be positive, right? Here we have a positive number, and then here also we need a positive number. That means c should be negative. That is why c is also negative here. Then the last identity, alpha beta plus beta gamma plus alpha gamma is equal to c by a. Here c, in place of c we have negative b, and a is 1, so it is negative b. See, alpha beta gamma all are positive, means this should be a positive number. If this should be positive, means b should also be negative. Otherwise, minus b will not be positive. So we can say that a, b, c all are to be negative. So in the question, it is given that at least one of a, b, c is non-negative. No, that is not true, right? Actually, a, b, c, all the three should be negative. This is the last question. P of x is given as kx square plus x plus k and has equal roots. Then the only value of k for which this quadratic polynomial has equal zeros is 1 by 2. Anyways, what is given? This given quadratic polynomial has equal roots. That happens when the 0. That is, inside the square root we have b square minus 4ac. When this is 0, then only the polynomial will have equal zeros. So we can take it as b square minus 4ac equal to 0 or less than 0. Here, in place of a we have k, in place of b we have 1, right? In place of a we have k, in place of b we have 1, and in place of c we have k. So let us give these values here. B square will become 1 square minus 4 into, in place of a we have k, in place of c also we have k equal to 0. See, then 1 square is 1 minus k, 4k square equal to 0. That means 4k square equals 1, right? We can take this minus 4k square to the other side. So we can take it as 4k square equals 1, or we can say k square is 1 by 4, right? K square is 1 by 4. That means k is square root of 1 by 4, right? So it can be plus or minus 1 by 2, right? Square root of plus or 1 by 4 means it can be positive or negative. But in the question, it is given that the only value of k, is 1 by 2. That is false. It can be 1 by 2 or negative 1 by 2. That is the only reason why it is false. Okay, hope all the kids or all my students understood what I have taught. Thank you for watching.